All right, so what I got today is the third section of this Chapter 8, which is exploiting Android devices. And we'll talk about it, but it's pretty short, and a good bit of it is about this Drozer tool that we're not using. But I got the Metasploit project working, and I plan to demonstrate it after this. So let's take a quick look at the remaining issues here, although we make this as big as it can be. All right, so we've been through that, and so today we're going to talk about a few more issues of exploiting the device. All right, so you have this JavaScript interface. If it loads content over HTTP, not HTTPS, and is running an old version of Android, very old now, then you could just inject JavaScript code and that would run right in the browser. But this is so old, not too many people have phones that are that old anymore. The Sony Xperia loaded ads over HTTP, and so you could just use any man-in-the-middle technique like burp to inject code. This, by the way, is true of some companies. They update things. In fact, I was just talking about this on Pulse Security Weekly, and the other guys there said that even though major products like Chrome or Windows, if it downloads an update, it will cryptographically verify the update before using it. But they say a lot of Internet of Things devices don't. They download the update and just take it. And so if you can alter the network traffic and give it the wrong update, it'll fall for it. I don't think Android phones will fall for that anymore. But anyway, so the Drozer agent is something you could have you installed on the phone. You'd add some code to the page, which would load the code from a remote site and inject that. And so some apps manage their own update rather than relying on Google Play, which is, of course, likely to be much less secure because we talked about this. The Google Play Store has a lot of really strong security features, including certificate pinning. So it would be better to just use that, but if they want their own update mechanism, then they have to have the install package's permission, and maybe they will be unsafe on the network. And so here's APK replacement. This is the Drozer, like Drozer's tool like Metasploit, and I'll show you Metasploit later, which is what I'm going to use. Drozer was an old tool. Unfortunately, both Drozer and Metasploit, as far as I can tell, have not been updated enough to keep up with modern Android versions. And I even found a page today when trying to understand this from some of the Metasploit developers saying, we just don't consider Android a priority. Anyway, so the Drozer agent defines a new schema, pwn, to run a code, and then you inject Samsung's Universal MDM client, mobile device management. These are what you have if you work at a company. I've got one on my phone because it's a two-factor authentication token from one of my consulting companies, and therefore they have to have some control over your phone. You put on a mobile device management profile, and now the company can see what apps are on your phone. They can see if you're putting on the updates. They can see if you jailbreak it. They can remote wipe it if you tell them you lost it, and stuff like that. And no company will trust your phone until you have one of these agents on there. So any package can be installed by invoking this URL. This was Samsung client, and the thing about it is, you know how to read this a bit now. This is the Android manifest. It defines a scheme called SMDM, and then it listens, and notice what it doesn't have is any permissions. So any package can just go to this, you just go to this URL with STM, and it will install that package. So that's the kind of sloppy coding. It's very much like command injection. You let anybody access this without permissions, just like an open API call, and the app itself is browsable, so it can take it from a web page, and it has install packages, so you can use this app to install your packages. All right, it will just pop up a box saying a new version is available, and when you click OK, it's installing whatever you asked for, whether it was the right thing or not. Didn't verify it. So you can have drive-by attack, and another thing you can do, by the way, is you can install an app with no permissions, and you can add the permissions later by exploiting vulnerabilities. This tends to happen. Now, there are drive-by downloads that automatically download when you visit a site and offer to be plugins. When they do this without any interaction at all from the user, they tend to patch that vulnerability. Safari had this vulnerability a few years back. And if you went to a site and you tried to download one file, it would tell you, but if you tried to download 5 files, they would just go on without asking you. They patched that, though, but there's always something. And so here, in Android 7 or earlier, if you allow unknown sources, you have to do that in order to install from an APK file. You can only install from Google Play otherwise. Android 8 or higher, you have permissions configured on a per-app basis, whether you want to let it install unknown apps. And you'll see this popping up in the projects if you download the APK onto the phone and then install it. Now, when the boot process happens, there's a signal sent when the phone boots up. And apps that are listening for that can then automatically do things when the phone boots up. So you can use this to run your malware. You can also load it in an iframe, but that's faster. It takes immediate effect. You don't have to wait for it to reboot. Now, also newly installed apps now will not receive the boot completed intent. Intent is the signal from one app to another. All right. And so now Chrome won't download an APK automatically. You have to trick the user into downloading it. And you have to trick the user into clicking something to launch it. But you can put up a deceptive page like this that says there's something fun here, but you need a extension to see it. You're hoping they'll just click on it, and what that's really doing is agreeing to download the data, the file. Now to say, I mentioned a app might not request any permissions. I don't know how important this is because I think most users don't pay any attention to the permission screen. Studies have shown it pops up saying this app needs the following 10 permissions. Users don't generally read through it and say, wait a minute, why does it need to see my photos? It just says, oh sure, give it whatever permissions, I'm trying to get it to work. But anyway, if you do think your users are actually that smart, then you can have an app that doesn't request any permissions, and then it can use vulnerabilities to change that. And this is called breaking out of the sandbox. Now, if you have a kernel exploit, then you can escalate to root, and you can do this, of course. But there are other ones. There was one I think we talked about previously where you could, anyway, there are vulnerabilities in various versions of Android that let you add permissions without getting proper user feedback. And so here's one, a command injection. The app had a simple command injection. It created a command line, dump state to data log, and then it took data from the user to finish the log. And it ran this as system. So this is a classic command injection, just like the ones we're doing in 129S. They have a line of code that is passed to the command interpreter running with high privileges, and it includes data from the user. So you can inject junk there, and here where you put in the // dev null, semicolon, then ID going to SD card. So this is just a proof of concept that will take the ID and put it on the shell code. So it's going to write a tag to mark this box showing you did have command injection. All right. So that's the kind of thing you can do to install an app without permission or change permissions without notifying the user, because you have a privilege escalation exploit that lets you run a system. Here's another one, object input stream. Was another vulnerability. It didn't check whether an object being deserialized is actually serializable. And so this deserialization exploits are very big, where you have a blob of data which is going to be unpacked at the other end, and therefore you can smuggle in unexpected things which are misinterpreted at the other end. In fact, there's a new one current right now in many Linux distributions, a tar vulnerability. Tar is a very old way to compress files, like zip in Windows. Well, if you have a tar file inside a tar file, which is legal, and you arrange the outside tar file to have a size of 0, then, because now you have two size markers, and the code in a popular library to unpack tar files gets fooled by that, and ends up letting the tar file write files to an unexpected location. So you're able to overwrite files that are later executed in gain code execution. This kind of thing keeps happening. Jeff Forrestal is a famous ethical hacker. He's the guy that discovered SQL injection. And now he also found the fake ID vulnerability, which is the one I'm going to talk about. He's a guy with quite a few accomplishments in the world of hacking and security. So the fake ID vulnerability happened like this. There's a function to verify the certificate is actually signed by its issuer, and that function was missing in versions of Android. This, by the way, was also true of Internet Explorer version 3. Internet Explorer version 3 would check that a certificate was signed by a company, but it would not go to make sure that it had a chain going back to a trusted root authority. So you could put in a self-signed certificate, and it would just accept it. And these kind of things keep happening because nobody notices, right? You go to a secure site, it works. It's encrypted, everything's fine. You go to an insecure site, it works. There's no problem for normal users. This kind of weakness is not obvious. Anyway, so any app certificate could claim to be from any user. So all you had to do was set the issuer feed to Adobe, and now you had high privileges, and you could then do high privileged things. All right. So getting the user data off a phone is what most people want. Now once you can install a malicious app on the phone, like Drozer, or for that matter, the Metasploit app, then you can record the microphone, read and send SMS, read contacts, location, screenshot, and all this jazz. And this is what the expensive tools like Pegasus do that we hear taking over phones. Now, SE Linux is the secure Linux, and it has a lot of security features, but you can turn them off if you have high privileges. So you can just turn them off. Drozer has some commands to turn them off if you have enough privileges. And you can record a video on the phone, not just a screenshot, and then you'd be able to get unlocked patterns if they're using this thing, where you have to draw like a path through the dots to log in. You can steal files from the SD card. Now it requires read external storage permission. You can extract Wi-Fi keys. Those are just stored here in wpasupplicant.conf. You'll find the login keys, the passwords for all the Wi-Fi networks. Same thing's true in the keychain in Mac OS. If you can log into a machine, you can get the Wi-Fi passwords. And the Gmail account tokens are stored in a SQLite database. They're not passwords, but they're tokens. So I'm not exactly sure how good they'll do you, but they might be able to log into that token. And third-party apps, of course, as I've shown in all the projects, they might store the passwords in plain text or with bad encryption various places, and we've been finding them in the projects. It's a popular thing for apps to do. And so you can crack these things. The gesture.key, there's a cracker at one of the links, and password.key you can crack with Python. If you download these files, they are sort of hashed, a reflection of login data, but you can crack them with known tools. And any app with context can read the clipboard. Password managers put passwords in the clipboard, and you can turn on an extended clipboard that stores the last 20 items. Samsung gives you that, but Dailymotion doesn't. And you can send keyboard presses and taps with the input command. You can specify the location to tap. You can dump screen and show screen dimensions. It'll tell you how big it is. So screen is 1536 by 1952. And then you can force a tap. And so 800/975 is going to tap Drozer here and launch it, which is a malicious app on there. So you don't have to wait for the user to tap it. If you have ADB access, you can force the tap. And you can extract application data with physical access, and this is what cops do all the time, right? They seize the phone, plug it into something, then they want to extract the data. You can back up everything for all the apps that haven't explicitly forbidden backups, because, of course, you do want to be able to back up your app data, your emails and such. So, all right. But, of course, you'd have to have ADB permissions here, and I think also high privileges to get into all the apps. Maybe not high privileges to run a backup, though. I'm not sure. It'd be interesting to try. All right, so let's try the Kahoot. This is 8C, and there it is.
I love these things.
Oh, good. Most people do.
There's an echo in here. He always says that.
What's that?
There's an echo here. I always say that every week.
Yeah, well. That's the idea, yeah. I learned it from the Air Force's Cyber Patriot, which is aimed at high school students. You know, and I said, that's good, I'm going to use that. You got to make it fun. If Android isn't what? Android, Drozer. Well, Drozer, that's right. As far as I can tell, Drozer hasn't been updated. It's a hacking tool from the author of your textbook. And but Civ did get updated by somebody else, and maybe somebody has actually updated Drozer. But the publisher of your book doesn't seem to have stayed with it, which probably means it didn't turn out to be that important. There's probably some other tool that's better, but it's not Metasploit. I've tried that. So I don't know what people actually use to hack into Android phones right now. It would be good to know. Anyway, what we're doing here, this is true of all my courses, we're not really learning the modern techniques that real criminals use, we're learning the fundamentals of how it works, which is what you generally get in an academic environment, you know. The basic principles are what you get. That's why the criminals that have tried to take my classes just drop out and say, this is stupid, I want to know how to steal credit card numbers today. I don't want to learn about 5-year-old exploits, because that's not our purpose here. There are special places they go, like online chat rooms, to talk to other criminals to learn that. And they sneer at me because I don't know that. I don't actually know the current technique.
That's good, you're being ethical.
Yeah, it's because I'm here to defend her, really. I'm not an attacker.
Good.
Yeah. Anyway, all right, let's give it a try. All right, so what is it safe to load over HTTP? Yeah, nothing. And in fact, I just saw in the news today, either Chrome or Firefox announced that in a month or so, they're going to start putting up an error message for every HTTP page, saying, don't load anything over HTTP, what's wrong with you?
Cool.
Which is probably the right attitude, yeah. All right, so which method allowed privilege escalation back in Android 4.4? Yeah, that was, oh, I thought it was this fake ID, but I guess it was the object input stream. Let me flip back in the slides since I don't remember that myself. Android 4.4. Ah, here it is. Yep, Android before 5. Yeah, this is the one that involved a serialization exploit, where you have some kind of malicious serialized object which, when opened up, has unexpected effects. That keeps happening. All right.
Yeah.
All right, so which file might contain passwords from email clients? Apparently accounts.db. Now, I haven't tested email clients, actually. That would be kind of an interesting thing to do. I tested other stuff like, so I never found that, but I guess you could put it there. Now, the right place to put it would be the Android key store, but there are probably some clients that put it to stupid places. There certainly are for every other category of app. And which utility lets you simulate user screen taps? Yeah, that's the input command. All right. So, you're Steve. Good, yeah. All right, and good. And, all right, good. So, let me stop this recording.